So welcome to this first podcast on the Panacea project. My name is Dudley Curtis from the European Transport Safety Council, and my guest today is Dr Selpi from Chalmers University of Technology in Sweden. Hi Selpi, how are you doing?
I'm doing great, thank you.
Nice to see you.
Same here.
So first, what is the Panacea project? Well, it's an EU-funded research project looking at how to use the latest technology to help professional drivers with their fitness to drive. So that means managing things like fatigue, stress, alcohol consumption, and drugs, all things that can harm road safety if not managed properly. So over to you now, Selpi. Could you just start by telling us a bit about where you work and what your role is in the Panacea project?
Yes. So I work at Chalmers, as you mentioned, and within Chalmers, I work at the division called Data Science and AI at the Computer Science and Engineering department. So my role in the project, I have a few roles in Panacea. The first one is to lead the work on developing the methodology for fitness to drive assessment. And this is exactly what this podcast is about. And then the other two roles is related to leading the task on developing the data models in the projects, designing and developing data models for the project, as well as the leading the task on analyzing the data and consolidating all the results. So in the first role that this podcast is about, I work with different partners in identifying the different sensors that we need, what type of data we need for the purpose of this fitness to drive assessment. In the end, we want to be able to use this data from these different sensors to create algorithms that can make final assessment of fitness to drive.
Thanks, that was really helpful. So the Panacea project is all about using data from a range of sensors to help make sure professional drivers are fit to drive safely. So could you describe for us what all these sensors do and why that's important?
Yes, so we have in total 12 different sensors in the project. So 4 of them are used to measure alcohol. So 3 of these 4 to measure alcohol on breath, and then 1 of them is to measure alcohol on sweat.
Right.
So they're quite different there. And then we have 1 sensor to measure drug. And then we have 3 sensors that are used to measure fatigue. So 1 of them is to measure fatigue continuously in the vehicles. And 1 is to be used, let's say, when the driver or the shuttle operators are on break.
Mm-hmm.
And we have also 2 sensors that are used to, 3 sensors to measure stress. And then drowsiness, 1 sensor for drowsiness, and also 1 other sensor for measuring cognitive distractions. And actually, I missed 1 as well to measure cognitive load as well. So yeah, 12 different things in the project. One of the sensor, what we call this biomathematical fatigue model, they use also like a fitness tracker as well to take into account the sleep history, sort of sleep data from a fitness tracker.
Well, that's brilliant. Thanks so much for that overview. It's really a lot of sensors and there's a lot of names to remember there. So that was
Yes.
great, and it's really interesting. Now, I mean, most people watching will be familiar with an alcohol sensor because these are used across Europe by the police when they're on the lookout for drink drivers, and it's fairly simple. You blow into it, and it shows whether or not you're over the legal alcohol limit. But it's not always that simple, is it? Detecting things like stress and fatigue is more complex. As you just mentioned, the Panacea project is using a whole range of sensors looking at all these different factors. So how did you begin figuring out how all these sensors could work together?
Yeah, so yeah, it was not easy, but we take different steps in this case, step by step, really. So first of all, we try to find out what this sensor is all about. what was the intended purpose for that sensor, and when it's supposed to be used, let's say, and then how it's supposed to be used, and then what type of measurement they have, and then how long the measurement that they collect will be valid for. And therefore, if we want to use that for making assessments, then we know how long this assessment will also be valid for. And that sort of information. And once we know all of this, we can then design as such so that we can cover the different phases when we want to measure the fitness to drive assessment with this different sensor. And in this Panacea project, we try to be holistic, meaning that we try to assess fitness to drive at many different phases. For example, when the drivers or shuttle operators are in the vehicles, and before driving, maybe they're still in the office, and even outside of their working hours as well, to get some idea about their fit to drive possibility for the next day. So it really is a whole range, and we even try to measure their fitness to drive in this case during their break time as well. Yeah, to cover all these different phases, kind of. So once we know all these different sensors, we know when we want to use or when we want assessments, we make the experiment as such, then we can make an algorithm to be able to help us assess what we want to assess. That sort of step that we have gone through so far.
Yeah. Okay, great. So, I mean, I understand the project has a way of scoring different types of what we call impairments. So that can be things like fatigue and stress and alcohol and so on. And these scores will add up to a decision on whether or not a driver is fit to drive or whether some other actions need to be taken. So could you describe the different categories for us and then what the different outcomes can be?
Yes. So in terms of the different outcomes, in this case, is beside this fitness, beside this fit or not fit to drive, there are also something in between. So we try to make these like levels of assessment. So let's say from before we decide something that a person is not fit to drive, there may be like a recommendation level there that we recommend not to drive. And even before that, there could be two other levels. In this case, we have 5 levels in total that we agreed in the project, from fit to drive to not fit to drive, and all based on the criticality in this case. And to make this type of 5 categories for this, what we call the final assessment, we also make the Panacea score or categories that you mentioned there. This means that from each of the impairment type, we also make some categories of impairment level, we call. I mean, for drugs and for alcohol, they're very easy, meaning that we follow the regulations. So for drugs, it's basically the category is just whether the drug that we want to test is present or not present. So we take the zero tolerance approach. For the alcohol, basically we take this, we know some threshold that is used, and therefore below the threshold is basically one category, and then above or equal to a threshold is another category. For the other 4 impairment types, they are pretty similar in terms of we have these 5 categories that gives this different level. It is a bit like, for example, no stress, or let's say low stress, and then medium stress, something like that, until severe stress. And the same with fatigue. Fatigue maybe it seems that no signs of fatigue, let's say, and then the others maybe with some signs of fatigue, but there is no fighting for sleep to close eyes, for example. For the others, maybe signs of fatigue plus the person is fighting sleep. There are signs of fighting sleep and things like that. So we made all these 5 categories as well.
That's really fascinating. So, I mean, the next question should really be about countermeasures, i.e., what are we going to do about it when we realize that a driver may be not quite fit to drive or definitely not fit to drive and so on. But I'm hoping that we're going to look at that in a future episode of this podcast.
Yes.
So the thing I want to talk about now is you've developed this system, you've developed these categories, you've developed this scoring, we're seeing how all the sensors interact. Can you tell us about how it is you're working with real drivers in real driving situations to test this, and what will you do with the feedback you get from testing the system in the real world?
Yes, there are lots of things that one can do with those feedback. So I can give example that we have used two of the sensors, in this case for alcohol and for drug detectors for the roadside assessment. So those two sensors have been used in Norway. And even from that experiments only, we have got some feedback from both the drivers who have used the sensors, but also from the police who conducted the test. So those feedbacks have all been used now by our partners in the projects to improve the sensor design, for example, and things like that. And then right now we have an ongoing experiment to collect the data. Some have been collected now for the what we call the baseline period. That means that the period without this countermeasure that you mentioned.
Yeah.
And then the next one will be we just started actually now the collection for the period for the what we call an evaluation period. That's where this countermeasure is also included. So basically, once we get all this data from this type of experiments, then we can analyze what's well, one thing is to measure how accurate, let's say, all the sensors have been, and then that would help us, of course, to make assessment whether that type of sensor will be used to make a Panacea, not Panacea, but to make a fitness to drive assessment system. And then from there, we can also understand whether the countermeasure we have designed in the project would be useful, actually, to help combat whatever issue that we found. And yeah, further from there, there's a lot of things that could also be then used in terms of making policy, for example, or making suggestions, in this case, for future research, and things like that. So I'm looking forward to analyze those and then get to know, what would be the next step from here.
Indeed, and we're looking so much forward to seeing the results. Well, thanks so much, Selpi. That has been a really useful insight into how your bit of the project, and it's a big bit of the project, has been developing. There are so many crashes linked to working drivers in Europe, and this research is really important to helping us reduce these needless deaths and injuries. So that's it for today's podcast. Thank you so much for joining me, Selpi. To find out more about the project, search for Panacea Fitness to Drive, and we'll see you in the next edition. Goodbye.
Thank you.